In this video, I'm going to be teaching you guys about the three types of AV blocks that are very high yield for step one. Basically, on step one, the test writers know that you cannot interpret EKGs because you're really just beginning in your kind of clinical path. So, there's only a limited number of EKGs that are fair game. And because the pool is so small, AV blocks are so high yield. Because again, aside from sinus rhythm, AFib, or A-flutter, the three AV blocks are really fair game, so you're probably going to be asked a question on them. And that's why they're high yield, and that's why we're going over them today. So before we go into the AV blocks, here is normal. You have a P wave, a QRS complex, and a T wave. What we're going to be concerning ourselves with today is really the PR interval. That is the distance from the beginning of the P wave to the beginning of the QRS. Now, normally, on a normal EKG in normal sinus rhythm, the PR interval is less than 200 milliseconds, which is 5 little boxes on an EKG. In this example of normal, it looks like we've got about maybe 3.5 to 4 blocks, so this is normal. If it was greater than 5 blocks or greater than 200 milliseconds, then it would be prolonged and we would have to think about an AV block. So again, this is normal. So we're going to start with the first degree AV block. And before I do that, I just want to say what it is and what the presentation will be on the exam. So an AV block is just as the name implies. It is a block in the conduction system down from the SA node to the AV node, so the His-Purkinje system never gets activated correctly, and therefore the heart can't beat efficiently. So think about it. On the test, you might be given a clinical vignette where a patient is experiencing dizziness, syncope, a slow heartbeat. Whatever the case is, it's all related to the fact that the heart can't squeeze and give you that nice good ejection fraction in time because of the electrical conduction abnormality. So a first degree AV block looks like this. And basically what you have in a first degree AV block is just prolonged PR intervals. They are constant, they are prolonged, and that's it. So whereas in the normal I showed you a nice pretty little PR interval that was less than 5 boxes, a first degree AV block is a PR interval that's greater than 200 milliseconds or greater than 5 little boxes. And I've drawn in these reddish arrows to illustrate that to you. Now for second degree AV blocks, there's two types. The first one is called Mobitz 1, also known as Winky block, and the second one is known as Mobitz 2. Now you do have to know the difference, but I have a nice little memory hook or mnemonic for you that'll help you out. A Winky block looks like this. And what happens is the PR interval gets progressively longer before a QRS is dropped. So usually there's about 2 to 4 beats and then you drop a beat or you drop a QRS. So what we see here in the example, and I've again drawn in those little red arrows to show you, is that PR interval lengthens, gets longer, and then you drop a beat. Because the conduction abnormality, you conduct, the heart's trying to squeeze and the signal goes through delayed. Heart tries to squeeze, the signal goes through even more delayed. Same thing happens, and then the signal never makes it down to the His-Purkinje system, and you never get that QRS, which represents ventricular depolarization. So, the way that you remember this is longer drop, that is a Winky block. Longer drop, that is a Winky block. Okay? So what you're looking for in Winky block, again, the PR intervals are still greater than 200 milliseconds because they're prolonged, but you're getting PR intervals that are progressively elongated before a beat is dropped. That is Winky block. Another way to remember this is some people say Winky block gives you warning. Just think of those W's. Winky block gives you warning. The PR intervals are gradually lengthening and they're warning you, yo man, I'm about to drop a beat. Check out my EKG. That's Winky block. That's also known as Mobitz Type 1. Now Mobitz Type 2 is a little bit different. In a Mobitz Type 2, the PR interval is lengthened. It stays lengthened. It's not getting progressively longer. They stay elongated, but then a beat is dropped. So the way that you can think of a Mobitz Type 2, it's almost like a first degree AV block that has a dropped beat in it. Because the PR interval is still greater than 200 milliseconds and it's still constant, but somewhere downstream you drop a beat. Now look in the example here. That green down arrow shows you where a QRS complex should be, but the beat is dropped. Meanwhile, the PR interval is still lengthened, as you can see by the green little ticks. That's a Mobitz Type 2. So again, Winky block gives you warning. Longer drop, that is a Winky block. Mobitz Type 2 is just a prolonged PR interval that drops a beat. You need to know the differences, but these are just two subtypes of a second degree AV block. Now, the last one we need to talk about is a third degree AV block, and I've dedicated an entire slide to it because it's really important that you be able to pick this out, because this is probably the highest yield in my opinion. So a third degree AV block is one where the atria and the ventricles contract independently of one another. They both work, they both squeeze, but there's such an abnormality in the conduction system that they basically say, I'm just going to do my own thing. So the atria are squeezing, the ventricle are squeezing, and there's no connection between them. Now, because of this, the EKG has a very characteristic finding. What you'll tend to see are a couple things. First, constant P to P intervals and constant Q to Q intervals. What does this mean? So even though the atria and the ventricles are contracting independent of one another, the interval between themselves is still constant. So let's look in the second EKG strip I have on this slide. Look at the bottom arrows where you see the P waves. They are all at constant intervals. Even though the atria are doing their own thing like little rebels that they are, they're constant. Look at the intervals, P to P to P to P to P. It's all the same interval because even though the atria is doing its own thing, it still has rhyme and reason to it in itself. Look at the top where the R waves are. They're still at constant intervals. Even though they are beating independent of the P waves, they are at constant intervals. Now, that's very characteristic of a third degree AV block. The other thing that's very characteristic that you have to keep in mind is that because the P waves and the QRS complexes are going to be appearing independent of one another, it's possible that P waves are buried within QRS complexes, and it might be hard for you to find P waves. So if you look at the first strip on this slide, in some of these examples, it looks kind of funky, right? I mean, we can't really discern P waves, QRS, and T waves. The reason that this is because you're having some overlap, if you will, where the P waves are almost entirely buried in the QRS complex. Look at the second QRS beat in the first rhythm strip. You see that little thing right in front of it? That's a P wave that's basically buried in the QRS. Now, this is kind of easy to spot because I pointed it out to you, but on the test, it's possible that you're given a rhythm strip. They're going to be bradycardic, again, because it's an AV block. The patient's going to have dizziness. Maybe they fainted, whatever. And then they show you this weird strip, and you're like, I don't know what this is because I don't see P waves. These are really big, long QRS complexes. What the hell am I looking at? Just relax. Look at the intervals. If the P to P is constant and the Q to Q is constant, you're already on the right path. If you can't find P waves, maybe they're buried in the QRS complexes. If that's the case, you've got yourself a third degree AV block. So now let me just summarize what we've gone over today. AV blocks are conduction abnormalities in the heart where signals are not properly propagated down from the SA node through the AV node into the His-Purkinje system. Because of this, people with AV blocks experience bradycardia, dizziness, and syncope. A first-degree AV block is one such that the PR interval is greater than 200 milliseconds or greater than 5 little boxes on an EKG. There are no dropped beats in a first-degree AV block. In a second-degree AV block, there are two types. The first type is a Mobitz Type One, also known more commonly as a Winky block. In a Winky block, the PR intervals get progressively longer before dropping a beat. On EKG, the PR interval will be greater than 200 milliseconds and get longer for a few beats before a QRS complex completely disappears. The mnemonic to remember this is that Winky block gives you warning, or longer drop, that is a Winky block. In a Mobitz Type 2, the PR interval is greater than 200 milliseconds, it's constant, it doesn't get progressively longer, it stays elongated, but then you drop a beat. A second-degree AV block is basically like a first-degree AV block with a dropped beat. And lastly, a third-degree AV block, as you see here on this slide, is one where the atria and ventricles are contracting independent of one another. The P to P intervals are constant, the Q to Q intervals are also constant, but because they are independent of one another, oftentimes the P waves are buried in the QRS complexes and it makes EKGs really hard to read. Because of this, these are high yield. All right, guys, go through this once or twice. It's high yield, it's going to be helpful, and I wish you the best of luck.